in example 21, we are told that under 2.7 that you can use combinations of transformations together with the modulus graphs and an understanding of the domain and the range to solve problems. Example 21 is telling us, given the function tx is equals to this, where x is a real number, sketch the graph of the function. Sketch the graph of the function. And I would want us, before we sketch the functions, I would want us to identify how many transformations we have. Upon x, there is an addition inside, which is -1. This is a transformation. And then the whole thing is multiplied by 3. This is another transformation. And then we add -2. That is the third transformation. We have 3 transformations upon what would have been the very original function of y is equals to x. This is where we start. And of course, y is equals to x. It gives us something like this. Easily, y is equals to x. But again, y is equals to x modulus. We can first of all choose to effect this graph by -1, or we can choose even to module this part. Either way can work. Okay, let's choose to module this part first, because we have just from understanding this. So we would wish to have all the x, the positive values of x with the corresponding values of y, and because x is moduled, we do not have the value of x when it is negative, but we have the values of y's when x was supposed to be positive. So when x itself is moduled, we have seen this before, we only need to reflect the graph of y is equals to x along the y-axis. Reason being, what y was when x was positive, let's say 1, is the same thing that is going to be y when x is -1. Remember, x is not allowed to be negative value. And in this case, that is now the graph of x modulus of x. So we need to go further to get y is equals to modulus of x minus 1. And this graph now, which is already moduled, there is an addition inside. There is an addition inside. According to this transformation, there is addition inside, which means it's horizontal translation of -1 step. -1 steps, which means it is horizontal translation of one step. Remember, our a here is negative, so negative minus 1 is +1. And what does this mean? All x values plus 1. So our graph now takes a different twist. This is the graph of y is equals to the modulus of x -1. And if we may want to capture it underneath here, we would wish to have all x values plus 1. Here x was 0. 0 plus 1 is going to be 1. Here x was -1. -1 plus 1 is going to be 0. So let's talk about a graph that looks like that. And this is now the graph of y is equals to modulus of x minus 1. Having done that, you can already see that that is now multiplied by 3. And this gives y is equals to 3 x minus 1 modulus. And you can see this is multiplication outside already. This is multiplication outside already. So we are going to talk about multiplication outside, which is multiplication outside is a vertical stretch, of scale factor 3, because our a is 3, meaning that all y values times a 3. So what is the y there? Y there is 1. 1 times 3 is 3. So we are going to have a sketch that again looks like this. Y here is still 0. 0 times 3 is still 0. So we are going to have something like that. After which we get now the final translation. Which is y is equals to x minus 1 modulus minus 2. And you can see there is addition outside. This graph is now going to have addition outside. What is addition outside? Addition outside. This is vertical translation of a steps. And our a is negative 2. So vertical translation of negative 2 steps. Vertical means all y values minus 2. So even what we are having here is y, 3, is going to be minus 2. And we're going to have our final submission here, which is 3 minus 2, 1. And this is going to be 0 minus 2. Then our graph talks of, let's name this particular point. This was 0. So minus 2, 1. This is a 0, 1. Remember, all y values are going to be this is 1 minus 2 rather, not because this one was 1, this one was 1, 0, 1 minus 2, and therefore we are talking of all y values minus 2. So that is it. We have been able to sketch, and that is actually part A, and you can call this graph of 3 x minus 1 minus 2. And finally, this is our final result. All right.